Alright, going to have a look at some number patterns here, which are again very common in GA type tests and happen to be my favorite type of problems to solve within GA. Alright, so these number patterns follow the same rule. Find the missing number. Alright, so 5 and 50, the difference is 45. An important thing we could notice is that times 10. I'll write that in there, times 10, 5 times 50. Alright, 7, and we don't know what this number is. We might start off thinking it'll be times 10, so it might be 70, which is actually in the answers. But let's keep going. No, 8 times 10 is not 128. That's actually 8 times 16. Right, now a way you could easily figure that out would be to know that 128 is in the powers of 2. It's 2 to the power of 7. Okay, so if you were to go through, 2, 4, 8, 16, 32, 64, 128, 2 to the power of 7. So you would know that 2 to the power of 3 is 8, 2, 4, 8. Okay, so you need to times that by 16, 2 to the power of 4 to get 128. Alright, so it's an interesting pattern. It wasn't times 10. Let's go over this one. Alright, 11 times something to give us 242. 11 times 2 is 22, so 11 times 20 will be 220. That leaves me 22. That's another 2 times 11, so that's times 22. Right, now you could see a relationship here. Alright, 22 is double 11, 16 is double 8, 10 is double 5. Alright, so I think the answer over here is going to be that we need to multiply by double the first number, which is 14. 7 times 14, 7 times 10, 70, 7 times 4 is 28, add them together, 70 plus 28, 98. So the answer will be 98 over here. Alright, so yeah, that one, probably a good idea to write the answer out underneath there so you can quickly establish the pattern there. Someone with good number sense would quickly see that 10 is double 5 and 14 is double of 7. Alright, let's move on to the next one. Find the missing number. They follow the same rule. Alright, so we've got that's 2 to 18 is 2 times 9, but that rule doesn't apply here. We're adding 9, we're adding 15, but this one we're taking away numbers. Alright, so let's look at the other alright, well I can see a relationship between 39 and 13. That's divide by 3. Don't know what this variable is, that's what we need to find. But again, we see over here the divide by 3, 75 divide. Again, having good number sense, you would see that straight away. So I'm pretty sure over here it also needs to be divided by 3. So to get this answer, so you would work backwards. So 13 times 3 equals that. 25 times 3 equals 75. 17 times 3 equals 51. So we should be pretty reasonably safe that it is 51. It is in the answers, B 51. But let's try and work out the rest of it. So let's assume that is 51. Let's try adding these numbers. 9 plus 18 equals 27. Have to add 12 to get to 39. Plus 12. 12 plus 27, 39. Knowing that this is 51, I should just write that in there so we don't forget it. Yeah, again, we will add 12, 39 plus 12, and 36 plus 27, 63, plus 12 gives us 75. Alright, so the rule was adding those two numbers together, adding 12 to that to give you the middle number, and then dividing by 3. So 51 works out fine there. Alright, next one. These number patterns follow the same rule. Find the missing number. Alright, 9, 25, 86. Here's the blank number that we need. Alright, we would straight away see 2 plus 7 equals 9, but that doesn't seem to work on the other questions. What about adding the first two? No, that's not going to work either. Alright, something you can see reasonably quickly is thinking about square numbers. What's 9 squared? 81. So it's pretty close to this number. So maybe it's got something to do with that. What's 5 squared? 25. Reasonably close to that number. What's 2 squared? 4. It's not so close to that number, but it's smaller in scale, right? Alright, so let's say we're having to do something between these two numbers to get this. Let's say that we have to square that one, gives us 81. And for this number, let's say we have to get the square root of it, which is the opposite basically. And that would work. That would give us 81 plus 5 equals 86. So if we said let's square that one, and then we'd have to get the square root, what would we need to get? We'd need to get adding 4. So the square root of which number is 4? Would be 16. And that would give us the answer of 29. Actually, I should just move the 16 up a bit, I think, to put it up above so we don't get confused. So 16's up there. That would mean, and the square root of that would be 4. That would give us 29. Right, let's try this. So 2 squared is 4. Square root of 9 is 3. Gives us the answer of 7. Alright, so you're squaring the first number, finding the root of the second number, and adding them together. So that means the answer is C, 16. That number needs to be 16. Alright, so you would want to have a pretty good knowledge of square numbers and square roots in order to be able to find that pattern. Alright, now I posted this problem to the Facebook group recently, and someone solved it pretty quickly, which was impressive. Alright, so the first step I would make here is to look at the difference between the numbers. That's pretty much what I do in any pattern, and I'll write it down. So that's 12. Here it's 15. Here it's 27. 72 take away 45 is 27. Now what you would see if you're very observant is that 21, if you reverse the numbers, you get 12. 51, if you reverse the digits, you get 15. 72, if you reverse the digits, you get 27. So that seems to be a pattern. So you're reversing the digits of the first number and subtracting that from the first number to get the second number. So we put 13 will be the difference. 31 take away 13 equals 18. So the answer should be A, 18. So you can see the thing that the quality that these problems all share in order to be solved is you have to have a really good number sense. All right, you need to be very aware of your times tables for starters, right? Then other patterns like cubes, squares, logical connections between differences and initial variables. So being able to identify in the first one, for example, that you need to double the first number, right? In the second one, that you were dividing by 3. See, I think they pick numbers like 39 and 13 very specifically because most children only memorize their times tables up to 12. So, you'll have a lot of kids who've learned their times tables perfectly up to 12, and then you get to 13 and they're just stumped on it. So it's separating the kids who are just rote learners from the ones who can actually apply some thinking to knowledge outside of that scope. Same thing with square numbers and square roots, right? I'd imagine a lot of children would have really struggled with that one. And the inverting numbers one, I think, yeah, you really would want to do a problem like that at some point to understand that that pattern is even possible.